We'll take a look at some matrix properties. First of all, two matrices are said to be equal to each other only if all of the corresponding elements are equal to each other. So that means, first of all, their sizes have to be the same in order to be able to compare element by element. In MATLAB, we have the function is equal. We pass to it two matrices, and it will return logical 1 for true if the two matrices are the same, if they are equal, or logical 0 if they're not, or if they're not the same size to begin with. Another matrix property is the following. A matrix is said to be square if it has the same number of rows and columns. So a lot of the other properties that we're going to look at are just for square matrices. So these are properties for square matrices. We say the main diagonal, or frequently just called the diagonal, of a square matrix is the set of elements A sub I. So in other words, the row and the column indices are the same. So the matrix sub 1, 1, 2, 2, 3, 3, and so forth. The trace is the sum of these values on the diagonal. MATLAB has a built-in function trace. You pass to it a square matrix and it'll return the number, which is the trace, which is the sum of the values on the diagonal. A particular kind of matrix is a diagonal matrix. A diagonal matrix is a matrix for which all of the elements that are not on the diagonal are 0. So there could be some zeros on the diagonal also, but the definition is everything that's not on the diagonal is a 0. MATLAB has a function diag that can actually be used in two ways. If you pass a matrix to the diag function, it returns a column vector consisting of the values on the diagonal of the matrix. The other way you can call the diag function is if you pass a vector to it, it will create a diagonal matrix with that vector on the diagonal. So remember, for the function diag, if you pass a matrix, you get a vector. If you pass a vector, you get a matrix. Some more square matrix properties. We say that a square matrix is symmetric if all of the elements A sub ij are equal to A sub ji. So in other words, the values that are opposite the diagonal from each other must be the same. So A sub 1, 3 is equal to A sub 3, 1, for example. So again, if you look at the diagonal, you'll look at the values opposite each other from the diagonal, then they have to be the same in order for the matrix to be symmetric. Another very special matrix is called the identity matrix. So a diagonal matrix is the identity matrix called I if all of the elements on the diagonal are 1. So recall that a diagonal matrix means that everything that's not on the diagonal is 0. And in this case, an identity matrix has all 1s on the diagonal and all 0s everywhere else. And again, it's a square matrix. This is a very important matrix. It's used all the time. So MATLAB has a built-in function that will create an identity matrix for us that's called I. Of course, the letter I is already built into MATLAB as the square root of -1, so this function is called I, EYE. Pretty silly. But we have this function I, you pass to it an integer, for example, I of 4, and that gives you a 4 by 4 identity matrix, again, that has all 1s on the diagonal, 0s everywhere else. Another kind of matrix we can have is called a banded matrix. That has a main diagonal, but also subdiagonals directly above and below it. So basically you end up with 0s in the upper right-hand corner and the lower left-hand corner, but you can have bands above and below the diagonal. A particular kind of banded matrix is called a tridiagonal matrix. That's a special case that has 3 diagonals. So it has one main diagonal, and it has one subdiagonal above it and one subdiagonal below it. Other special case matrices are called upper triangular and lower triangular matrices. An upper triangular matrix is a square matrix that has all 0s below the diagonal. So you have non-zero values on the diagonal and above it. So the upper part is where you have the non-zero values. There could actually be 0s on the diagonal above, but the definition is that you must have all 0s below the diagonal. MATLAB has a function try_u. You pass to it a matrix argument, and basically it'll make that matrix into an upper triangular matrix. So whatever you had below the diagonal, it'll replace all of those numbers with 0s. Everything else on the diagonal and above, it leaves alone. A lower triangular matrix is basically the reverse. It's a square matrix that has all zeros above the diagonal. So the non-zero values are in the lower part of the matrix. And MATLAB has a function tri-L that will receive a matrix argument and it will make it into a lower triangular matrix. These are some matrix operations that we've been doing all along. Let's take a look at how we refer to them in mathematics. So a matrix transpose, as we know, interchanges the rows and the columns of a matrix. In mathematics, we write that as A with the superscript of capital T. So that's the transpose of the matrix A. In MATLAB, as we've seen, we use the apostrophe as the transpose operator. Another common matrix operation is to take a matrix and augment it with something else. So matrix augmentation means adding columns, or perhaps another matrix, to the original matrix. Some techniques that we're going to use in linear algebra involve doing this. We start with a matrix and we augment it with an identity matrix with the same size, for example. In MATLAB, of course, we can do this by just concatenating the matrices together by putting them inside of square brackets. Here's a definition of a matrix inverse. If the result of multiplying a matrix A by some other matrix B is the identity matrix, then B is said to be the inverse of matrix A. So the inverse of matrix A is written in mathematics as A with a superscript of -1. So again, if we take a matrix A, we multiply it by its inverse, then what we get is the identity matrix. Again, that's the matrix that has all ones in the diagonal and zeros everywhere else. How you actually figure out what the inverse of a matrix is not so easy. There are some linear algebra techniques to do that. MATLAB, however, has a function called INV that will compute a matrix inverse for us.